Hello everybody. The topic of our today's session is stability and particulate properties of high performance lubricants, a comprehensive characterization study. My name is Stefan Küchler. In the main part, we will present two case studies. First about stability analysis, second about particle droplet size characterization of high performance lubricants. Our first case study demonstrates the use of analytical centrifugation, so we can directly see here the propagation of the interface towards the filling height. What else can we see? As mentioned, from red to green, this is the measurement time color coded. We see also where is the filling height, the meniscus. We see that here there is some dropping down, means that there is also some very tiny creaming layer. On the right side, we have here indicated the clear phase and the cream layer, which is not yet compact. For more details on the procedure, I recommend our technical note at our platform Dispersion Letters. We look here at the time of 2002 because in the beginning there was no change between the samples. As we typically would like to differentiate also even more samples, which might be even more different in their stability. Therefore, here it makes sense to compare the samples after 1 hour, because then we have a much larger gap between the two curves. And that means that also in the bar chart, we have here a larger gap so that more samples could be effectively compared and differentiated. For these two samples, we get the same ranking. We apply again our instability index algorithm. That means we have the same region of interest applied to all samples as before. And now we see that we get here a nice ranking between the different samples. It's going up and down a little bit because the order of the samples is with increasing sample number. Lubricants ranking is confirmed by customers, not shown here. We get identical ranking regarding standard test procedures also for different emulsion preparation conditions. We get a fast ranking. We can lower the costs. We have a quick return of investment for the instrument. We have a low environmental impact. We continue now with our second case study. When we compare the left and the right sample, we see that here the spacing between the profiles is much larger. And this spacing is a direct measure of the separation velocity of the individual fractions of particles. As both pictures have been recorded under the same conditions, then we can also say, okay, if the spacing in the profiles is larger, there must be droplets of higher migration velocity in the left sample compared to the right sample. So we can do a reliable characterization of lubricants, including challenging samples, by different procedures. We have here independent results that we get from using the LUMiSizer, including velocity and droplet size distribution, including additional methods, including direct accelerated stability analysis as shown before with the instability index, and also in agreement with visual inspection, which is always available. Independent results give identical ranking for heavy-duty lubricants. Also, an accelerated comparative shelf life in a few hours instead of months is possible with this instrumentation. The multi-wavelength approach, which is required, for example, if a broad range of extinction must be covered. They are faster than conventional methods. They are time-saving and anticipate long-lasting separation. They are environmentally friendly by using smaller sample volumes and avoiding additional chemicals, cleaning of samples, containers, and tools.